One, two, three. Hello, class. My name is Carlos Barrera, and I'm going to be talking about the decorator design pattern. The decorator design pattern works by simplifying the attachment of additional responsibilities or features to an object without adding responsibilities to an entire class. If you've ever worked with, most of us have, if not all of us have worked with object-oriented design, this is also known as a wrapper. In other words, a decorator design pattern is able to add responsibilities to individual objects dynamically and without affecting other objects. A good example of the decorator design pattern would be the development of classes. When developing our product, spending trends in graphical format, that's when the demonstrator would be used. So, one, two, three. Hello, class. My name is Carlos Barrera, and I'm going to be talking about the decorator design pattern. Decorator design pattern. The decorator design pattern works by simplifying the attachment of additional responsibilities or features to an object without adding responsibilities to the entire class. If you've ever worked with object-oriented design, which most of us have, this is also known as a wrapper, which we have used. In other words, just like a wrapper, the decorator design pattern is able to add responsibilities to individual objects dynamically and without affecting other objects. Why would we use this? Well, a good example of a decorator design pattern would be the development of classes when developing our product spending trends in graphical format. The reason why the decorator design is appropriate for displaying spending trends is because we will just be changing the object skin versus guts. Implementing a class that covers all possible graphical displays would be wasteful because most of the graphical displays won't be used by our users. Most users will only choose to use one or two displays at a given time. Instead, we can format the display classes and add responsibilities as the user asks for them. So if the user wants to use a bar graph or pie chart, we'll modify the graphical interface as the user asks for. Upsides of using the decorator, it gives you more flexibility and more than static inheritance. When the decorator design pattern responsive with the decorator design pattern responsibilities, with the decorator design pattern, Hello class, my name is Carlos Barrera and I'm going to be talking about the decorator design pattern. The decorator design pattern works by simplifying the attachment of additional responsibilities, also known as features, to an object without adding responsibilities to an entire class. Another name for the decorator design pattern is a wrap. It's a wrapper. Most of us have actually dealt with object-oriented design and we've had to deal with wrappers, and this is the same thing. In other words, the decorator design pattern is able to add responsibilities to individual objects dynamically and without affecting other objects. A good use and a good example of the decorator design pattern will be the development of classes when developing our products, spending trends in graphical format. The reason why the decorator design is appropriate for displaying spending trends is graphically is because we will just be changing the object's skin versus its guts. Implementing a class that covers all of the possible graphical displays would be wasteful, and more because most users will only use a display or two at a time. Instead, we can just format display classes and add responsibilities as the user asks for them. The upsides of using the decorator design pattern are just two. They're really important, but kind of simple. The decorator design pattern gives you more flexibility than a static inheritance. With the decorator design pattern, responsibilities can be added and removed from an object at runtime by simply attaching and detaching decorators or wraps. In contrast with inheritance, it requires to create a new class for each additional responsibility. The removal of inheritances also requires substantial modifications of the classes instead of modifying a single object. A good example is that let's say you have a parent class and then you realize that the parent class shouldn't have a feature, shouldn't have a method, shouldn't have a method, and you want to remove it, but your subclasses have already inherited those methods. The removal of that method is going to be a pain because then you also need to go and modify your subclasses. With the decorator design pattern, you wouldn't be you wouldn't be inheriting as much because your parent classes would be simpler, right? Actually, we'll just move to the second part of the upsides of using the decorator design pattern. The second upside is it avoids feature-laden classes high up in the hierarchy. It avoids feature-laden classes high up in the hierarchy. What that means is that inheritance can uh, uh, 2, 3. Hello, class. My name is Carlos Barrera, and I'm going to be talking about the decorator design pattern. The decorator design pattern works by simplifying the attachment of additional responsibilities to an object without adding responsibilities to an entire class. In other words, the decorator design pattern is able to add responsibilities to individual objects dynamically and without affecting other objects. The decorator design pattern is also known as a wrapper because we've all taken object-oriented classes. We've all had to deal with wrappers before. It's basically the same thing. No, not basically. It is the same thing. A good example of a decorator design pattern would be the development of classes when developing our product's spending trends in graphical format. The reason why the decorator design pattern would be appropriate for displaying trends is because we will just be changing the object's skin versus its guts. Implementing a class that covers all possible graphical displays would be wasteful because most graphical displays won't be used. At least they won't be used at the same time, or some users might not find the use of some graphical designs, so there's no reason to implement a class that covers all possible displays. Instead, we can format the display classes and add responsibilities as the user asks for them. So if a user wants a pie chart or a bar graph or a box plot, etc., we can add those additional graphical interfaces as the user asks for them. Some upsides, really, there's just two major upsides. The first one's it gives you more flexibility than static inheritance. With the decorator design pattern, responsibilities can be added and removed from an object at runtime by simply attaching and detaching wrappers. In contrast, with inheritance, it can require to create a new class for each additional responsibility, and the removal in inheritance is also more complicated, it's more substantial because you need to modify the class that you're inheriting from, or yeah, basically. Moving to the second upside is that it avoids feature-laden classes high up in the hierarchy. Inheritance can attach unnecessary responsibilities to subclasses, while decorators only add responsibilities as they are needed. This allows the construction of simpler classes and optimization of overhang. It also simplifies the addition of responsibilities because the probability of conflicts is minimized due to the simplicity of parent classes. So overall, the upsides just have to do with the ability to add more features to specific objects without having to worry about how they're going to interact with their parent classes or other subclasses. Well, I'm going to pass over the mic to my partner and he'll explain some downsides and implementations. Thank you.